So let's talk about some simple tests for divergence. This first one is pretty simple. If I have a convergent series, that means I'm adding up infinitely many things together, which means I have to take a limit, and that limit exists. So it must be that the limit of my individual summands, the numbers that I am adding up in my series, in the limit they must go to 0. Now this is only a one-way inference. As we just saw with the harmonic series, the limit of the individual summands in the harmonic series goes to 0, but that doesn't stop the harmonic series from diverging. This right here is just an observation for series, which we already know converge. So if I have a series whose summands don't tend to 0, then I automatically know that that series diverges. So this is an even handier way to talk about my series from before. What if I take 1 plus 1 plus 1 plus 1 plus 1 plus 1? What if I try to add up infinitely many ones? Well, my individual summands, those aren't going to 0. So for that reason, I can just write it off and say, okay, that series does not converge. Now, since we define these infinite series in terms of limits, all of the old rules for combining different limits still work. And the most useful of these are these 3 rules right here. So number 1, constant multiple rule. If you're adding up a series and each summand, each term in the series is some constant multiple times a sub n, you can just factor out your constant multiple. So factoring still works, but only as long as you are factoring a constant out of an infinite sum. Number 2 is the addition rule. If you are trying to take a series and all your terms look like a sub n plus some different b sub n, and as long as those 2 different series will converge by themselves, well, then we can just take the series of the a's first, compute whatever that's going to be, take the series of the b's next, and then add up those resulting limits. Once again, I want to emphasize that every summation, every infinite sum is secretly a limit, the same way as every integral is secretly a limit. Once we get more formulas up our sleeves, we won't be using these techniques directly every single day, but we got to start somewhere. Finally, the last rule that I want to talk about on this slide is the difference rule. And this is just the addition rule, but for subtraction. So if I'm taking a series and I can express my terms as sum an minus sum bn, sum being the English word some, then I can break up my series, add up all the a's first, add up all the b's second. As long as both of these different series also converge, then we are in business and we can just subtract the sum of the a's and the sum of the b's.